Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Green Booklet, Practice Test 1, specifically Unit 19, questions 62 to 63. So in this unit, we had to consider a method for determining the concentration of bilirubin in a sample of serum which also contains hemoglobin. So we've been given two equations. We've been told that obviously A45, A75 represents the absorbance at these specific wavelengths. K represents the absorption coefficients of bilirubin and hemoglobin, and C is their concentrations. So the easiest way to get your head around, I guess, this unit is by just substituting our known values given in the stimulus into equations 1 and 2. Once we do this, we generate these two equations. So just from these two equations alone, we can answer both question 62 and 63 in a heartbeat. So just by looking at these equations, they're pretty powerful because what they're telling us is that at both absorbances A 455 nanometers and 575 nanometers, the absorption of hemoglobin is going to be the same at both wavelengths, whereas the absorption of bilirubin is going to be different. So straight away you know that if we can obviously remove our absorption spectra for hemoglobin from absorbance of 455 and 575 nanometers, we can calculate the concentration of our bilirubin. So we can get the absolute concentration here. So now if we take a look, at question 62, it's asking us for absorbance at 455 nanometers to equal absorbance at 575 nanometers. It's obvious if we just, again, look at the figure or the equations here, because both the absorbance of hemoglobin is at 455 and 575 is the same, then we just have to make sure that this is the same. So the absorbance for bilirubin. So the only way to do that is if we just make bilirubin concentration equals 0. So if we make this equal 0, and that's 0, it's just going to be 0, 0, and they're both going to be equal. So they're both wavelengths are going to equal 0.01 times the concentration of hemoglobin. So the answer for 62 has to be D. Now, if we move on to question 63, again, if we take a look at our equation, we can clearly see that the absorbance of hemoglobin, the absorbance of hemoglobin at both 455 nanometers and 575 nanometers is going to be the same. So therefore, we can actually now calculate the absolute concentration of just bilirubin in the solution because of this. Because bilirubin's wavelength is different at both, or its absorption spectra is different at both wavelengths, we can actually now calculate the absolute concentration. So when the question says, in order to determine the concentration of bilirubin at, say, 455, as well as measuring at 455, the absorbance is measured at 575, because if you look at the answers, it has to be, if you look at 63, it has to be D, because hemoglobin is absorbing equally at both those wavelengths, which means it makes it easier for us now to actually calculate the concentration of bilirubin. So that's why, because if we can keep this, I guess, what's the word I'm looking for here? If it's a fixed value, if it's not changing, then we can calculate using the changing values. So that's why the answer for 63 is going to be D. So if you have any more questions about manipulating these sorts of equations or absorption spectra and anything relating to absorption spectra, you can post them in the comment section below, or you can contact us directly. We'd love to help you. Thanks for your time. Bye now.